In this video, we're going to talk about frequency distributions for quantitative data. We've already discussed frequency distributions for qualitative or categorical data, so we're going to discuss frequency distributions for quantitative data, the numerical data. Okay, a frequency distribution is just like those for qualitative data, except it's divided into classes rather than in categories. So let's look at the example of Old Faithful. The geyser Old Faithful in Yellowstone National Park alternates periods of eruption, which typically last from 1.5 to 4 minutes, with periods of dormancy, which are considerably longer. The following table represents the durations in minutes of 60 dormancy periods that occurred during a recent year. Construct a frequency distribution using 5 classes and 55 as the lower class limit for the first class. So this is the major difference between categorical and quantitative data for frequency distributions, is that we have to have classes, class limits, okay? So when we discuss class limits, we have what we call class limits, and we have the lower limit to the upper limit. Okay, and we first have to calculate what we consider the class width. The class width is the highest value minus the lowest value divided by the number of classes. So a lot of times whenever I get data like this, the first thing I'm going to do is put it in order from smallest to largest. This way I can find the highest and the lowest value quickly. This data is actually already in order from highest to lowest for you. So I know that for my class width, my largest number is 116 and my smallest number is 55. And we want 5 classes. So we have 116 minus 55 is going to give me 61 divided by 5, and that gives me 12.2. Well, we don't usually use decimals in our class width, and this is one of the things that goes against almost all rounding rules. Where we're talking about class width, we always go up to the next whole number. So we're going to round to the next whole number. We always round up. Okay? That's going to be something that we have to get used to, is that it's always going to round up. So in this particular case, we're going to round up to 13 for our class width. Now, when we discuss class width, what we're going to do is we're actually going to add the class width down. It's not the difference between the lower limit and the upper limit, it's the difference between each lower limit. So I'm going to take 55 plus 13, and that's going to give me 68. And then I'm going to add my 13 again, and so 68 plus 13 is going to give me 81. I will continue adding 13, and 81 plus 13 gives me 94. Then add 13 again. So 94 plus 13 gives me 107. So I now have all of my lower limits. So my upper limits here, if this class starts at 68, this class is going to end at 67.9. In other words, the value that is the closest to 68. If the third class begins at 81, the second class is going to end at 80.9. And we put that 0.9 on there in case we have decimals or anything like that. It doesn't jump from one class to the other. It's a continuous value. And so we can have everything up until we actually hit 81. So this one's going to be 93.9 because this one starts at 94. This one is going to be 106.9 because this one starts at 107. Now to get this last one, what I'm actually going to do is I'm going to take this 107 and I'm going to add 13. So 107 plus 13 would be 120 if I made another class. So the upper limit here is going to be 119.9. So in other words, I'm looking at where this class could end. Okay, so I have to add the 13 to get the other position. Now frequency for this class is literally just counting up how many numbers fall between 55 and 67.9. So if I look on my table, 55 to 67.9, there's 3 of them. So I'll come down here and put a frequency of 3. Then I have 68 to 80.9. So 68 to 80.9 is actually only 1. Then I have, let's see, I've got 81 to 93.9. So 81, that's going to include all of these. It'll include all of these because I'm going to 93.9. So here's where it will stop. So it includes all of these values. And if I count those up, that should be 33. Now if I look at the fourth category, that's 94 to 106.9. So that's going to start here and it'll end here at the 105. So it will include all of these, and that's going to be 22 numbers. And then my last value, which is 107 to 119, there's going to be 1 of those. So we've counted up the frequency. So if it's not, your data is not already in order from smallest to largest, I would suggest you do that. It would be easier to make sure that you get all of them in your frequency distributions. Okay? Then we need to look at what we consider midpoint. Midpoint is going to be the middle of the class. But what we do is we take the lower limit plus the next lower limit. So it's lower limit to lower limit. And then we take their average and we divide by 2. So for this first one, it's going to be 55 plus 68, the next lower limit. And we're going to divide by 2. So 55 plus 68 is 123. And we're going to divide by 2. So that's 61.5. So our midpoint for this category is 61.5. I do the same thing for the rest of them. So I will take 68 plus 81 and divide by 2. And I get 74.5. Now you'll also notice that my class width was 13. The difference between my midpoints is actually 13 as well. So I could just get my first one and then add 13 each time. Okay? And I would get 87.5, 100.5, and 113.5. Now this 87.5 came from 81 plus 94 divided by 2. This 100.5 came from 94 plus 107 divided by 2. And the 113 actually came from 107 plus that extra 120 divided by 2. That gives us our midpoints. Relative frequency has not changed. Remember to add up your frequencies. N is equal to 60, we hope, because it told us in the original problem that there were 60 dormancy periods. And so relative frequency is taking 3 and dividing it by your total number, and then we're going to round to 3 decimal places. So that's going to be 0.050. This is 1 divided by 60. That's going to be 0.017 if we round it correctly, because 1 divided by 60 actually gives us 0.0166666. So it looks like this. And so if we round to 3 decimal places, this is a 5 or larger, so that one goes up to a 7. 33 divided by 60, you have to remember your rounding rules. 0.550. 22 divided by 60 is 0.367, and that's because we end up with 0.36666, and so that's going to round up to 0.367. 33 divided by 60 was exactly 0.55. And then we have another 1 divided by 60. And so that's the same as our second group up here, 0.017. And if we add these up, we should come as close to 1 as we can. And let's see here, that's going to come up to, it actually comes up to 1.001, and that's because of these roundings, okay? So as long as you're close to 1, not 1.7 or anything, but even 1.1, but notice it's in the 3rd decimal place. That's okay. That's where we want it. So this is a frequency distribution for quantitative data. You've got to find your class limits, adding your class width down. Don't forget to round your class width up to the next whole number. Count your frequencies. Your midpoints are lower limit plus lower limit divided by 2. And your relative frequency is your frequency divided by your total frequency. And we round to 3 decimal places. So go ahead and try making some frequency distributions for quantitative data, and then let me know if you have any questions.